The space race. Something weird keeps happening on the moon. Well, here we have another video that is showing that the new technology that they keep sending to the moon doesn't seem to work as it did back in 1960s. So, we have a problem here, don't we, Scott?
Absolutely. They're claiming that there's something weird about the surface of the moon in this particular video. And in the 1960s, we were able to land vehicles there, so called like the Surveyor 1 and 2, for example. They landed successfully. They didn't tip over. There wasn't anything weird happening. They claimed that their sensors worked like their radar and everything else for their landing speed and everything else was working correctly at the time. But now today, they're claiming that something happens when they get close to the surface of the moon, that their instruments are not reading the lunar surface because there's something very strange about the lunar surface that interrupts their signals for all of their sensors. And that's why these vehicles either crash land, don't control the rocket thrust or anything else on it, or it simply can't read where the surface is and it simply crashes into the surface. One of them claimed that it was traveling too fast in a horizontal position, and so when it touched down, it just simply flipped over. Well, today's technology, the sensors we have on vehicles and everything else, self-driving cars, we definitely have the computer technology to correct all this stuff. But they're simply claiming here that there's something very strange about the lunar surface that stops this equipment from working. And if this is the case, then why would anybody be projecting anything traveling to the moon in a manned vehicle? If this particular ball of mass, of ball out here that we call the moon, has that much of an effect on instruments in unmanned craft, why would you send anything manned there today?
Well, I would think it would tip over just like this. Let's take a look back at the 60s when they started sending the Surveyor probes to the moon. It was Surveyor 3 that bounced a few times and then seemed to land okay. But now, when they send these new probes to the moon, one of the legs just touches the surface and it rolls over, and that's the end of it. So, what is going on? Why can't they land anything there today without all these problems? And yet they could land all these probes on the moon in the 60s without any trouble. It makes no sense.
Yeah, and apparently autonomously when there was absolutely no way to build an autonomous computer machine in the 60s. Yet they simply claimed that they land autonomously. It's unbelievable. My personal feeling is nothing had touched the lunar surface in the 1960s. That's my personal. That's everything was all simulation. And people can argue about that. You can make comments about it. You can do whatever and have a go at it. But that's my opinion. Everything was done using simulations. Any of the photographs, any of the orbiting stuff were done using, high power telescopes like we have today.
In this video, they're showing you that probe that the private industry sent to the lunar surface. What does it do? It comes flying into the crater, touches the rim, and just tumbles right into it. Are they claiming that they are receiving data from this probe after it just hit the side of the surface and tumbled in to the crater?
Well, that's at the South Pole, landing in a crater. And of course, you're looking at digital signals and it's not in line of sight of the Earth, so I don't know how they're receiving anything. And if it's being powered by solar panels, and solar panels, batteries, everything else would be dead at this point because the panels are facing the ground. Anyway, the new telescope is the Nancy Grace Roman Space Telescope, and it is here mounted on Earth. It's not launched anywhere, and it's better than James Webb, so has more capabilities.
Well, they sure seem to have a lot of trouble getting anything there, whether it's human powered or it's machine powered.
But if the best telescopes for observing space are here on Earth, then why bother launching anything into space to observe anything?
Yeah, but let's go back to the 60s again. In 1969, on Apollo 11, didn't they have moonquake detecting equipment? And then on later missions, didn't they have radiation detection equipment? What I don't understand is This equipment that's on the lunar surface was transmitting back to Earth. Some of it was. So why is private industry sending these machines back to the surface to measure radiation when it was all done back in those days?
Doesn't NASA claim those things are still operating today?
Is the equipment left by Apollo still transmitting today? No. None of the active systems left on the moon by Apollo missions are still transmitting signals today. Seismometers, Apollo missions 12, 14, 15, and 16 deployed scientific packages that included seismometers, magnetometers, and other instruments. These instruments transmitted data back to Earth until NASA shut them down in 1977 to save costs. They have been silent ever since. All right, so NASA shut them down to save costs. What does it cost to keep that nuclear power supply operating on the lunar surface? If it's there, it's going to be transmitting for thousands of years. You don't need to shut anything down.
Maybe they have to send somebody up there to clean the dust off the equipment. Just like what happens to the Mars rover. It gets cleaned up all the time. Maybe they have to send somebody there to clean it up. I mean, there's no polar bears there, but
Perhaps NASA's cosmic cleaning cruise stops on the moon first before they make their trip to Mars.
what I'm reading here, it says, while not actively transmitting, the seismometers are still there operating, but not in the sense considered working as they're not sending back data.
This is what ChatGPT has to say about the cameras. It says, TV cameras and communication equipment. These were turned off when the astronauts departed or after mission completion. None of those radios or transmitters are still operating. Why would you turn the cameras off before you left? That makes no sense. You would leave those cameras on and you would point them at the Earth. That's what normal people would do.
Well, considering the fact that the descent stage is left on the surface, and you've got a vehicle that's sitting there with enough kind of protection with all of the mylar and stuff on it, you think they would put enough equipment in there to power the cameras for a long period of time, some kind of radioactive generating facility for them. The descent stage did not have any such equipment like that on board. They consumed all the batteries, so I could see that the cameras themselves would run out of power shortly enough. They'd only be able to work part-time. They'd have to wait for the batteries that they left up there to power up to get charged up enough from the RTG and then run them.
But that still makes no sense. Why NASA would shut that equipment off when it has an RTG pack on it, which would keep that transmitter going for thousands of years. Think of all the information that they could be receiving over those years. You don't shut that stuff off. And it's same with the cameras. The cameras, you don't shut cameras off. You leave them running until they die.
Here's the other thing. You spend all of this money to put a rover on the lunar surface. It has camera equipment on it that is so-called can be operated remotely from the Earth. This is what they claim. Well, why wouldn't they hook that up to an RTG and solar panels so that it would continue to charge those batteries so that they could use that camera? Don't you think it would make a lot of sense to, if you've got all that battery power up there, to charge those batteries up to run those cameras? The rover having a remotely controlled, don't forget the TV camera was remotely controlled for the liftoff. Wouldn't you want to keep that camera active if you could operate that from Earth? Wouldn't you want to put an RTG on those battery packs before you left so that it would charge up and keep that camera operating?
Yeah, well, let's take a look at some of these probes. If you take a look at the Voyager probe, it's an RTG unit, same type of idea. Why didn't they do the same on the moon? Hook one of those up, leave the camera running, pointing at the Earth. Same with that seismic equipment. You could have that running for thousands of years.
Or at least even a few hundred. Working on Voyager for this many years, and they expected the RTG to be running it, to keep enough power running at the distance it's at.
So think about this. Here's the astronauts. They get into the craft, and the very first thing they do, turn the cameras outside to off. Are you kidding me? That makes no sense. You'd keep them running, at least so that you could get the takeoff from outside. You could point two cameras, one at the Earth, one outside. How many cameras did they have? They had one on the rover. They had one that they took out, stood up, and pointed at the LEM and moved it around the surface. So there's two television cameras. Then they had one on the side of the LEM. Why didn't they have that pointed somewhere? This makes no sense, and yet they leave and they shut them all off first before they leave. Oh, come on.
Why would you bother to shut them off? Why wouldn't you just let them run until they ran out of power?
Yeah, well, I think they shut them off because they didn't want people to see the fakery. That's what I think.
Well, that's exactly right. Because the one shot of them with them operating is on one set, and then the takeoff, they needed to use that simulator window and take it off from their fake plaster molds, right? With those cameras. That's a different camera operating to show that liftoff sequence. You have the first one where you're up off the gantry crane where the flag's blowing when it takes off, and then immediately you go to just the plaster mold and the camera pulling away from it. Those are the different shots you're getting, and then it goes into orbit around the plaster globe. So you get the first one off the gantry crane being shot up that you're so-called taking from the rover, remote controlled, and the one from inside the craft as it's taking off, so it's blowing shit around in the flag, and no dust, of course. Forgot about the dust on that. Up it comes on the gantry crane, and immediately it goes into the plaster mold one right after that. And that's why they had to state that the cameras on the surface were turned off.
Oh, that would have given the whole thing away.
Yeah, you imagine the television camera that was on Apollo 11 pointing back, it's out 100 feet out, is being powered by the descent stage. You should have been able to see at least part of the takeoff from that, even though it wasn't able to angle up, right? It should have shown the takeoff.
Well, the very first thing that they do when they get that camera out there is they point it at the LEM.
Yeah.
Have you noticed that? Because they want
Yeah.
to get the guy coming down the stairs and they want to show the big satellite dish that they're setting up.
The guys are on the ground to put it out that 100 feet.
Yeah, but how come they don't leave that running and then get the takeoff from that camera? How come they have to use the rover camera when they have two out there? Oh, wait a
Well,
minute, that's black and white. Oh, they want color pictures though. You see, they don't want black and white. So what? They had an extra color camera inside the LEM. A television camera, a color camera extra that they had in that LEM that they took with them. Westinghouse made it. They could have taken that camera and put it outside. Even though that camera's black and white, you would still point it back at the Earth. You see, these are the human qualities that make a real mission reality because that's what a human being would do that was there. You would point that camera back at the Earth and you would leave it running until it died. Even if it was 100 years or 1,000 years, you would leave it running. You would not just, oh, wait a minute, got to get back outside the LEM. Oh, wait a minute, here, we're up the top of the stairs. Oh, forgot to turn all the cameras off. So they walk back down the stairs, shut all the cameras off, and then get back in and take off. That makes no sense. And yet this is pretty much what they did. That's just not logical.
Well, let's just say you're going to leave the camera on and the equipment's going to function until the sun is no longer on that part of the surface of the moon. And when it comes down to minus 250 degrees, it's going to mess up the equipment.
If you point that camera at the Earth and leave it stationary, in the next month it's going to make a full circle and it's going to come right back to that same spot.
Yeah, and it's going to warm up again and maybe start operating again.
Yeah, possible.
Like as long as the mechanics of it doesn't get damaged.
But don't forget that had a Vidicon tube in it, which means that the heater is going to be running 24/7.
There wouldn't be enough power for that.
Yeah, but if it was on an RTG, it would have limitless energy. It would have limitless power.
It would be able to charge a battery back up again over time.
Yeah, but look, the Voyager crafts, and they had Vidicon tubes.
Well, then how come the RTG, so-called on the lunar surface, had 68 watts? Then you read the second PDF file that they come out with it, and then it's got 72 watts. And then you read the third one coming out, and it's got a little more than that. And then the final one that they come out, the nice color version for the RTG, is 1500 watts.
Well, that's no different than the battery in the PLSS, because when you look at the battery for the Apollo missions like Apollo 11, it was about 314 watts. Now, when you look at them, it says they're 400 watts. And in the PDF, Apollo 17 was 386 watts. And now online it's 400 watts at 16 volts. Okay, it was always at 16 volts. That was a 16-volt battery in there, which makes it even worse because if it was a 29-volt or a 24-volt battery, it's going to last longer. But this is 16 volts. If you take 400 watts, divide that by 16, you're going to get about 28, 29 amps.
Well, it doesn't matter how you look up these RTGs. They show you how many watts, but how many amps of power is it putting out? But you see what people look at, they go, oh, well, now the RTG is putting out 1,500 watts. Equivocate that to one breaker on your household panel at 120 volts. Well, it's not 120 volts.
When you do the calculations on the 16 volts at 400 watts, that's 25 amps. So that's going to give you 25 amps per hour because those are rated in watt hours, those batteries. The Sony camera that I used to have, that was made in 1969, Vidicon system with a reel-to-reel deck. That had a 120 volt step-down transformer to 12 volts DC. And I see that NASA had the same Sony camera. So that camera is running on 12 volts. Unless, of course, it was specially made for NASA to run on some weird, odd voltage.
But then the RTG would have to put out that voltage.
Yeah. As a matter of fact, it has to put out a higher voltage, right? Because it's going to be charging. So it's going to put out an extra.
A voltage regulator and an inverter.
Yep.
And you need a battery backup on it. Well, that's the same reason why you have a battery on any device that's running and having a charge coming in, and the battery is just like that big elastic band cushion for you, right? Where it can store it up and output it when it needs it.
Yeah, well, look at houses, look at anything. If you have a solar system, you're going to have a battery bank to charge those batteries, and then those batteries are going to go through an inverter, which is going to bump it up to 240 volts.
But that's your cushion when you demand more power, it's there.
Well, you tell that to the engineers who constructed the power supply for the Voyager 1 and 2 crafts.
Like I said, I thought the original set it had a battery with solar panels. And then they threw an RTG in there and took away everything else. You can't turn on and off stuff without a battery to give that extra push in there.
The RTG that's left on the moon, the output voltage is approximately 30 volts DC. Well, in the PDF, it is 29 volts DC. Power output around 70 watts at the start of each mission, decreasing slowly over time as the plutonium-238 decayed and thermocouple efficiency dropped.
So they're saying that it's, let's say it's 30 volts. Are they also saying that that's putting out 1,500 watts at the same time?
You take 70 watts, 30 volts, well, that's only little over 2 amps. What the heck's that going to power?
Nothing. I don't know how they keep changing their mind about this stuff, because they would have to go back and change all the PDF files on all of the electronics that's being hooked up to it, like the cameras and everything else, what they were converted to. And you don't see any documents on how they specifically, like you see the Hasselblad that they specifically made the cameras to so-called work on the moon, but you don't see anything about the television cameras or the DAC camera or anything else. And of course, the DAC cameras are running 16 millimeter film. What kind of film was that? How did it work on the moon?
Think about this. We're talking about plutonium-238. How is that going to decay in the amount of time that they are there? How is the thermocouple efficiency going to drop only in 8 hours?
Right. And of course, this thing is not shielded. Once they take the core out, that was shielded when it comes out. You see it in Apollo 12, you pull it out of there. It's no longer shielded. And the guy's camera is right there on his chest. Isn't that going to mess up the film?
Hey, that's a good point.
He's pulling the core right out. Even if you go near that thing when it's operating, it doesn't have any shielding on it.
As a matter of fact, that film that I put outside the microwave oven and hid it for 1 second, that's what that film would look like. It would just be completely ruined
as soon as they pulled that out of there. And of course, all of the film they have with them is going to be ruined anywhere they're near that bloody RTG. And now, when we were looking at the other stuff, why these vehicles are not landing, and they're saying, what's weird with the moon? Well, My theory is, of course, is that the lunar surface is so highly irradiated that it's simply damaging their equipment, their sensory equipment, and that's why when they get down within 5 kilometers of the lunar surface, they simply lose the signal. The things screw up. They don't know enough to shut off. They don't know how fast they're going or anything else. There's enough radiation. Look at the amount of solar flares. There's no belts around them taking that off. They're hitting a direct impact of radiation every time there's a solar flare, just hitting that lunar surface. It is being so highly impacted like that and irradiated, anything that gets close to it electronically is just going to fail. You can't have that kind of radiation. Causes interference. If you really wanted a prime example, let's go to the movie industry. Star Trek IV, The Voyage Home. Remember they were gathering this stuff off the Enterprise on the ship and they couldn't beam out because of the radiation? They're admitting it.
That reminds me of when Chekhov went to stun those two guys, and the guy said, "Go ahead, stun me." And it fizzes out, and he says, "Must be the radiation."
Yes, exactly. But they couldn't beam out. The two of them couldn't beam out when they were gathering the radiation.
Yeah, well, that just goes to show you radiation, what it does.
How do they communicate on the moon with their, 14 watts of power and their antenna pointing any odd direction?
So let's just take a look at the battery in the PLSS that was just used for the communication system. The VHF transmitter module required about 6 to 8 volts DC for its RF electronics. Its power amplifier stage likely used a higher voltage rail closer to 12 to 16 volts to drive the final RF output stage. The RF output power was 0.5 watts. And that's VHF amplitude modulated, but the electronic input power to the transmitter module was roughly 7 to 10 watts, including modulation circuits and inefficiencies. All we care about is the RF output power. That's half a watt. That's what's transmitting. That's what's coming out of that antenna on the back of that PLSS transmitter pack. Half a watt. That was going to the LEM, and then the LEM was retransmitting it like a repeater station back to the Earth. So that would work. The communications consumed 7 to 10 watts continuously. Don't forget, we have two different batteries here. We're talking about the battery that's sitting up at the top. Now the duration, this is interesting. So of course we have 400 watt hours divided by 8 watts is 50 hours of continuous transmission. And again, now they're going on 8 watts. But that's the input power. We want the output power. The output power is only half a watt. So the EVA operations meant the communication power was just a small fraction, which I agree. Then we come back to the water pump, and we come back to the relays, and we come back to the solenoid. There's no way that a 400 watt pack at 16 volts is going to last. You've got 25 amps there to work with. That's it. Which means 25 amps, you could keep a 25 amp light bulb lit for 1 hour, and that's it. So right. How were these guys out there for 7 to 8 hours on Apollo 17?
So the PLSS has a fan to blow the air across the sublimator. You have a water pump pumping water through their suit to keep them conditioned on there. They must have to have a heater in there too if they're cold as well. To heat the air up, you must have a heating element of some kind.
But when you look at the diagrams in the PDFs, I have looked and tried to find any writing that shows where that water tank was, where the water holding tank was. Oh, it's there all right. It's on the side. It's a big long cylinder on the side. Yeah. But they don't label it in any of those diagrams, and I don't know why.
Because it's not much bigger than a thermos bottle, that's why.
No, it's longer.
That's right. If it holds a half a gallon of water, I'd be surprised.
Nominal PLSS life support duration, 4 hours, 5 to 6 hours with margin. If only the transmitter were running at 8 watts, in theory, then it would last for 50 hours of continuous transmission, but that scenario is unrealistic because fans, CO2, scrubber pumps, sensors, and cooling took the majority of the power. Actual EVA operations meant COM power was just a small fraction, which is why it had a separate battery. But even they're saying here, that scenario is unrealistic. I mean, think about it. Fans, CO2 scrubber pumps, sensors, cooling, pumps for the water.
Are they saying that the CO2 needed a scrubber pump?
Yeah, there's a CO2 scrubber pump in there too.
Okay, that's even more. You got to be able to circulate that air in the suit out through that pack because you just can't let the CO2 build up inside the suit itself. It has to get out of that helmet. You have to have fans to take that air out of the helmet and get it through that CO2. Because if there's enough CO2 in the air, you're just going to pass out. Because your lungs, like CO2, they're more capable of exchanging CO2 than they are oxygen. That's why you can express it out of your system when you breathe out, and when you come in, you're bringing in the oxygen. But if there's CO2 there, you'll suck it right back in.
Well, that's really interesting, though. CO2 scrubber pump. So now that's another one we can add to the list that's sucking a lot of current away.
Yeah. But don't forget how efficient those fans would have to be in that suit to get it through the pack.
I have to laugh at this. ChatGPT is even saying that this scenario is unrealistic.
Yeah, like I said, the OPS pack is not much to keep you alive on if it can't replace what's in the rest of the PLSS. It's only going to give you a little bit of oxygen, that's it.
And it says continuous transmission alone wasn't the limiting factor, it was the life support loads that were. And that's what makes it unrealistic.
Pretty crazy stuff. I mean, like I said, they wrote a nice script. They built simulated equipment to perform the tasks and so they could film everything here on Earth, of course. And then, if you look at the details on it, because it's just simulated devices, they don't have to work as stated. The PLS pack only needed when they had their helmet on when they were doing the filming, they could take it off and the shit that's in the pack didn't matter anymore, right? Even if it quit working, they could just simply take their helmet off and say, hey, get me, I need some more airflow through here. And they didn't need to have all of that stuff. All they needed was an inlet and a nice fan blowing nice, clean, cool air inside of that suit the whole time they were running around. That's all they needed in that pack. And their Snoopy helmet on for communication. All they needed.
This is what is strange to me. It's claiming that the heater tanks existed, but for freezing prevention only. And the astronauts' metabolic heat and the electronics heat raise the water temperature naturally. So how is that going to happen when you are in the shade? And it's minus 250 degrees Fahrenheit.
You're talking a variance of 500 degrees Fahrenheit, from minus 250 degrees Fahrenheit to plus 250 degrees Fahrenheit.
The astronauts' metabolic heat and the electronics heat raise the water temperature naturally. Okay, fine. But that's not going to happen when you're in minus 250 Fahrenheit and then you step into the sun and you're at plus 250 Fahrenheit. How is that going to happen? How is that going to just change like that? It has to change on a dime.
Yeah, well, guess what? When you step down the ladder in the shade, when Neil comes down the ladder, he's in the shade. He's minus 250. And when he stands out in the sun, it becomes plus 250, just like that.
But how is the astronaut's metabolic heat going to raise that water temperature?
Not fast enough to compensate, that's for sure. And don't forget, the water is sitting out the back in the PLSS pack.
Then how much current did those heaters take? That's what I want to know. The water tank antifreeze heaters in the Apollo PLSS were low-pressure resistive heaters. Based on NASA's hardware specs, heater power draws about 10 to 15 watts each, PLSS battery voltage 16 to 19 volts, current draw per heater I over PV equals 10 watts over 16 volts, which is approximately 0.6 amps, or about 0.8 at higher power settings. Well, if you believe that, then as you said, you'll believe in Father Christmas. Father Christmas. Father Christmas. Father Christmas.